Hi class, this is Dr. O'Connor, and this is the second or last video for Chapter 3. Last time we stopped at the section where we were naming some common ions. So you should be able to name different ions. You should be able to determine the charges for the main group ions from the periodic table and so on. You also need to know these polyatomic ions that are in table 3.3. So make sure you know their name, their formula, and of course the charges on each one. That's very important because the next thing we're going to do is name some ionic compound. So let's go ahead and take a look at this carbonate ion here. So we see it has a carbon, 3 oxygens, and a -2 charge. So we treat this polyatomic ion as one unit. So think of that -2 charge applying to that whole unit. Also, for many polyatomic ions, the atoms are bonded together, but the bonds are not ionic. The bonds are covalent. And we'll talk about covalent bonds a little bit later. So for now, make sure you're able to recognize and write the formula for hydronium ion, ammonium ion, acetate ion, carbonate ion, hydrogen carbonate, also called bicarbonate. I will only hold you responsible for the hydrogen carbonate, although in homework problems you might notice that this ion will be referred to as bicarbonate ion, and some of the other ones also by that prefix bi. This here is chromate ion. You have a chromium atom, 4 oxygens, and a -2 charge. And then we have the dichromate ion, 2 chromium atoms, 7 oxygens, and a -2 charge. This is cyanide ion. Here we have hydroxide ion and hypochlorite ion. Here is nitrate ion. Now notice that this has 1 less oxygen than the nitrate, and it still has a -1 charge. So this is the nitrite ion. This is oxalate ion, permanganate ion, phosphate ion, and notice this is hydrogen phosphate, also called biphosphate, but again, I'll just hold you responsible for the hydrogen phosphate ion. And notice that we have the 1 phosphorus, the 4 oxygens, but notice there's a hydrogen here, and the charge is increased from a -3 to a -2. And then here we have the dihydrogen phosphate ion. Now we have 2 hydrogens. We still have 1 phosphorus, 4 oxygens, but notice the charge is increased to a -1. Here is the sulfate ion. We have a sulfur, 4 oxygen atoms, and a -2 charge. And here, notice this, we have a sulfur, 3 oxygens, and a -2 charge. So the sulfite ion has 1 less oxygen than the sulfate ion. So yes, you need to memorize everything in this table. Now, let's go down here. We're going to talk a little bit more about ionic compounds. So first, let's talk about the ionic bond. And so we have sodium. Solid sodium reacts with chlorine gas to produce solid sodium chloride. And we know that this is an ionic compound, and we know that the sodium atom transfers an electron to the chlorine atom, and we end up with sodium and chloride ions. So the ionic bond is the result of the electrical attraction between ions of opposite charge in a crystal. We'll talk about the crystal thing in a minute. So we know that opposites attract. So those are some very strong attractions between positive and negative ions. Let's take a look. Sodium chloride is actually in the form of crystals. And a crystal is a very ordered arrangement of these ions. And again, these ions are held together by these electrical attractions because of those opposite charges between the sodium ions and the chloride ions. So they're held together in a very ordered arrangement, and they're not able to move around. Okay, so these ions are packed very tightly together in, again, a very regular arrangement. So it turns out that each chloride ion, those are in green, will be surrounded by 6 sodium ions, and each sodium ion is surrounded by 6 chloride ions. So that crystal, if you will, is held together by ionic bonds, by those strong attractions between the positive and negative charges. Now, I will tell you that for an ionic compound, or for any compound, the overall charge has got to be 0. So for an ionic compound, the charge must be 0. That overall charge has to be 0. So let's go down here. Remember too, we start off with sodium and chlorine gas. So chlorine gas is a green toxic gas, actually. And sodium metal, you can barely see it here, it is very silvery soft. I can actually cut it with a butter knife, it's so soft. But when the sodium metal and the chlorine gas come in contact with one another, they go through this reaction where the metal will burn in the gas, and what do we end up with? Good old table salt, or sodium chloride. Okay. Anyway, we said before that for a salt, these are crystalline compounds, and it turns out that in these crystals, we have many, many ions that are attracted by these ionic bonds to their nearest neighbors. And we call the crystals ionic solids. And then these types of compounds we refer to as ionic compounds. So, first rule is all chemical compounds are neutral. In other words, the overall charge is 0. Let's take a look at how we write formulas for these ionic compounds. Chemical formula of an ionic compound will give us the ratio of anions and cations. So for example, for sodium chloride, we have a 1-to-1 ratio of sodium ion to chloride ions. For, let's look at this one, magnesium chloride, we have a 1-to-2 ratio of magnesium ions to chloride ions, right? We get that from the subscripts. So in the case of potassium ion and fluoride ion, we have a plus charge on the potassium, a -1 charge on the fluoride ion. Then think about it. In order to have a neutral ionic compound, then all we need is 1 of each for that formula. Okay, so a +1 and a -1 add up to 0. So this would be neutral. Okay, now if the ions have different charges, then we're going to need an unequal number of anions and cations in order to combine so that we have a net charge of 0. So in this case here, we have potassium oxide. This is the formula for it. We have 2 potassium ions for each oxide ion. Okay, so this shows us that we have 2 potassium ions plus 1 oxide ion will give us this formula for potassium oxide. So what we have is, let's check this. We have potassium ion has a +1 charge, but we have 2 of those. And then oxide ion is a -2 charge. So we add these together and the overall charge is 0. And that's how it should be. Same here. Here we have calcium chloride. So we have a calcium ion that has a +2 charge, chloride ion with a -1 charge. In order to balance those ions, we need 2 chloride ions for each calcium ion. That gives us calcium chloride. Again, let's add these up. We have a +2 for calcium, and then we have 2 chloride ions, each a -1. and that adds up to 0 for the neutral compound. So this is the correct formula. If I were to write the formula like this, well, we know calcium is a +2 and chloride ion is a -1. This would give us a +1 overall charge. That's not right. So in order to balance, in order to make the overall charge 0, we need 2 of these chloride ions, 2 -1s, right, for that +2 calcium ion. And then they, again, those charges add up to 0 for the neutral compound. Now, when we have 2 ions that have different charges, the number of one ion is equal to the charge on the other. What does that mean? Well, let's go back to the calcium chloride, okay? And let's just write this. We have calcium ion and we have chloride ion. Look what happens. See here we have the 2+ charge, but notice this 2 comes over here and this 1 comes here. Therefore, we write the formula like so. Okay? Same with the potassium oxide. We have potassium oxide. This is how we write the formula. Let's write the ions. So we have potassium ion with a +1 and the oxide ion with a -2. Notice what happens. The 2 goes here and the 1 goes here, and this is how we write the formula. Okay? Let's take a look at this magnesium phosphate. Here we have a -3 charge on the phosphate ion, a +2 on the magnesium, and remember the cation will come first. So let me write it this way, magnesium and then phosphate. So that 3 will go here and the 2 will go here, and this would be how we write the formula for magnesium phosphate. So what does the formula show us then? The formula of the ionic compound shows the lowest possible ratio of atoms, and we call that the simplest formula, or the formula unit. So the formula unit, the chemical formula that identifies the smallest neutral unit of an ionic compound. So in this case here, the blue spheres represent a -1, the red sphere is a +1. And so the smallest, think of this as being a crystal with a lot of ions, but the smallest unit that would still have 0 net charge would be a -1 and a +1. So this here would be 1 formula unit. Here, the blue sphere is a -1, the red sphere is a +2. So 1 formula unit then would be composed of 2 -1s. This would be 1 formula unit. So for example, let's say I wrote sodium chloride this way. And yeah, you can have 4 ions, 4 sodium ions, and 4 chloride ions. That's going to give us a net charge of 0. But that is not the smallest formula unit. This is incorrect. We have to reduce these subscripts to the lowest possible value. So here we have it, sodium chloride. Okay? So let's take a look at some properties of ionic compounds. And they are white, crystalline solids. And as we know, the ions are held rigidly in place by their attraction to their neighbors. So that means they cannot move about. They have very high melting and boiling points. For example, sodium chloride melts at 801 degrees Celsius. And it boils at 1,413 degrees Celsius. Ionic solids, if you strike them with a hammer, will shatter. And some ionic solids will dissolve in water. And guess what? The ones that do dissolve can conduct electricity. So remember in the beginning when we talked about some water solutions that contain these salts will conduct an electrical current? Now we know why. Because the ionic compounds that do dissolve in water, when they dissolve into ions, both positive and negative ions. So a few rules for writing formulas of ionic compounds. Determine the cation and the anion. Okay. You always write the cation first and the anion second. Never, ever use charges when writing a formula. So, for example, the formula for sodium chloride is this. If you write it like this, it is wrong. Okay? So never include the charges. You can include the charges when you're on your scratch paper when you're trying to figure out the subscripts, but if you're asked to write a formula, make sure it does not include the charges. If you have a polyatomic ion and it has a subscript, always put parentheses around that polyatomic ion, okay? Because the reason why, in this case, this 3 tells us there are 3 of these units here, okay? So let's go ahead and write some formulas for ionic compounds. Let's write the formula for the ionic compound that is formed when between chloride ion, so chloride ion, and magnesium ion. Now, we have to determine which is the cation, which is the anion. Magnesium ion is the cation, chloride ion is the anion. So magnesium is in group 2A. Therefore, magnesium loses 2 electrons. It has a 2+ charge. And chlorine is in group 7A, and it gains 1 electron to become the chloride ion. So now we want to write the formula. Here we have a 2+ charge, here a -1. So in order for these charges to add up to 0, we're going to need 2 -1s. So we would write the formula like so. We have 1 magnesium ion to 2 chloride ions. Let's try phosphate ion and the iron 3. Remember, this is a transition element. It can have more than 1 charge. So the cation would be the iron 3, and the phosphate ion is the anion. So iron 3 has a +3 charge, and then we write the formula for phosphate like so. Notice that the charges have the same magnitude. Both are of 3. So all we need to do is just write the formula like so. Now let's do one more. How about potassium ions and oxide ions? So potassium, that has a +1, that's the cation. Oxide ion, a -2. So now we can write the formula. We have a -2, so we would need 2 of these potassium ions. So let's write the formula, K2O, that's potassium oxide. One more I want to do is aluminum ion, and let's see, we'll do oxide ion again. Aluminum, group 3A, it has a +3 charge. The oxide ion, again, we know a -2 charge. And we'll bring this here and this here. So what we have is aluminum oxide. That is the formula. So you want to practice writing these formulas. Here's another one that I'd like to write. How about ammonium ion with dichromate ion? So ammonium ion has this formula, and this is the dichromate ion. So this has a -2 charge, right? And this has a +1. So I'm going to need 2 of these. So we have the ammonium and I'll put a 2 here, and then, so practice writing these formulas. And let's go to this problem here. Here we're told let X and Y represent an element. Element X reacts with element Y to give a product containing X2 plus and Y minus 1 ions. Is element X a metal or non-metal? Well, it's got a positive charge, so it is a metal. Is element Y a metal or non-metal? It's negatively charged. It is a non-metal. What is the formula of the product? Well, we have X2 plus and Y minus. We're going to need 2 of these so that our charges add to 0. So what we have is X, Y, 2. Okay. And what main groups of the periodic table are elements X and Y likely to be in? So we're just looking at main group elements. So anything with a 2 plus charge would be in group 2A, and Y has a negative 1 charge, so it would be in group 7A. Okay, so practice these. Now here we want to name ionic compounds if we're given a formula. First, we name the cation, we then name the anion, and we put a space between the words. So for example, here we have magnesium and sulfate. This would be called magnesium sulfate. Here we have one of those elements, tin, that can have more than 1 charge, so we have to use Roman numerals. So looking at this, we know that the tin has a +2 charge. Remember this 2 here. Remember we do that crisscross. So this would be tin 2 chloride, or in the old naming system, stannous chloride. Here, again, we have tin, which is the cation, and we have the chlorine. And notice the 4 here. So this means the tin has a +4 charge, and we would write it as tin 4 chloride. Of course, the older naming system would be stannic chloride. Let's do a couple more of these things. How about this one here? We have sodium and cyanide. So this would be sodium cyanide. And so here we have iron and sulfate ion, but we have a 3 here. That means the iron has a +3 charge. And remember, iron is one of those transition elements that can have more than 1 charge. So this would be iron 3 sulfate. Let's do another one. How about this one? Here we have sodium, that's the metal. And remember, this here is hypochlorite ion. So this would be sodium. We put the name of the metal, and then the anion, hypochlorite. Okay. Let's try another one. How about this one? We have calcium and oxygen. Calcium is the metal, so we would name it as calcium, and then this would be called oxide. And let's do one more. And how about this one? We have sodium ion. Sodium is a metal. Remember, that's the cation, is the sodium ion. So this would be sodium. And this here is the carbonate ion, sodium carbonate. Oh, here's some more that we can name. We have potassium and fluorine atom. So this would be potassium fluoride. Here we have iron and oxygen, but look at this. There's a 3 here. Remember, we did the crisscross. So this would become this charge. So this would be iron. Again, iron is one of those transition metals. This would be iron 2, oh sorry, iron 3, oxide. This is a symbol for gold, which is a metal, and we have chlorine. So this would be gold chloride. I know that's not something you hear of often. Here we have calcium and sulfate. So this would be calcium sulfate. And here we already did this one. This is sodium carbonate. Practice these. There will be several nomenclature questions on the exam. The last part that we're going to go through here is we're going to talk a little bit about these two ions here, the hydrogen ion and the hydroxide ion. This is one of those polyatomic ions that you had to memorize. Okay, so these are very important ions. Remember, the hydrogen ion is the cation, the hydroxide ion is an anion. And remember, a hydrogen atom contains one proton and one electron. But when it loses the electron, you can think of the hydrogen ion as just being a proton. The hydroxide ion, on the other hand, is a polyatomic ion, and the oxygen and hydrogen are covalently bonded to one another. We'll talk about those a little bit later. An acid is a substance that provides, so a substance that provides hydrogen ion. So hydrogen ions, when dissolved, in water. And some examples are hydrochloric acid, nitric acid. You probably use these in the lab. Sulfuric acid. Sulfuric acid has these two hydrogens. Okay. And then there's also phosphoric acid. All right. So you need to know these. These are the most common acids. So I do expect you to know the formulas and the names for these. So when we dissolve some phosphoric acid or hydrochloric acid into water, then they produce hydrogen ion and the corresponding anion. So for example, when we put hydrochloric acid, which we would write like this, hydrochloric acid, and when that is put into water, what we have is hydrogen ion plus the anion, which is the chloride ion. Okay? Now, a base, on the other hand, is a substance that provides hydroxide ions when dissolved in water. And some of the very common bases are sodium hydroxide, potassium hydroxide. Let me rewrite that for you. It's a little bit sloppy. It's hard to write neatly with this pen. Oh, let's see. Potassium hydroxide and barium hydroxide. So as you can see, if I put sodium hydroxide into water, it dissociates into sodium ions plus hydroxide ions. So I want you to know these acids and these bases. And we'll talk more about acids and bases a little bit later, but be able to recognize an acid and a base. Many of the acids, for example, hydrocyanic acid, if you notice, the cyanide ion is one of those polyatomic ions, and it just has picked up a proton. So many acids are the polyatomic ions that have picked up a proton. So I would expect you to recognize these acids and bases. For example, here's another one. Here's this one here. Remember, this is nitrite ion. This would be nitrous acid. Okay, so look at table 3.5 for the common acid and the anions that are derived from them. You'll notice that those anions are those polyatomic ions. The polyatomic ions can pick up a proton to become an acid. I want to show you the acetate ion. In your book, it's written like so. We can also represent acetate ion like this. Okay, so make sure that you know that these mean the same thing. These are both acetate ion. In fact, when acetate ion picks up a proton, okay, it becomes acetic acid, something we're all familiar with. Well, that's the end of chapter 3. And again, as usual, if you have any questions, please email me or stop by the office during office hours. If you can't stop by during office hours, then send me an email and we can set up a meeting time. We can even do a Blackboard Collaborate. So have a great evening.